Okay, so welcome back. All right.
Excuse me, sir.
जी please. जी इरफान.
सर यूजुअली रिसर्च में एक डिपेंडेंट वेरिएबल होता है और बहुत सारे इंडिपेंडेंट वेरिएबल और डिपेंडेंट वेरिएबल्स होते हैं.
जी please.
सर ऐसी प्रैक्टिकल एग्जांपल आप शेयर कर लें सर काइंडली के जिसमें इंटरडिपेंडेंट टेक्निक्स अप्लाई होते हैं, मींस कि उसमें डिपेंडेंट वेरिएबल नहीं होता, यानी कि इस तरह की कोई स्टडी सर.
हाँ, अभी जो PCA का डिस्कशन हम स्टार्ट करने वाले हैं ना, right? So in the context of this particular technique, I would be able to tell you, okay, for example, why you don't need to mention dependence versus independence. Okay, इस तरह ठीक रहेगा?
ओके सर, थैंक यू.
हाँ, और ज़ाहिर है जब PCA के डिटेल्स में हम जाएंगे, so then I will give you a specific example. But broadly, आप इसको इस तरह याद रखें कि initially, as a researcher, you should ask whether mentioning one or more of the dependent variables. फिलहाल तो आप concept ये है ना कि, for example, in the last semester, we were considering a very limited case of the dependence technique, जिसको हम कहते हैं regression analysis. Okay, so in that category, it was necessary that one variable should be declared as dependent and the others would be declared as independent. In this particular course, Ji? Sorry?
Screen share.
Okay. Thank you. I don't know. I usually forget this thing. Okay, I hope it is okay now. Okay?
Yes, sir.
All right. So when you want to carry out analysis of multivariate data, it very much depends on the interest of your research. As a researcher, it depends on your research question. And broadly speaking, your research question would be such that it would automatically seek the dependence of one variable or more than one variable on one or more other variables. As I was telling you that in the last semester, we considered one type of dependence technique, जिसको हमने कहा regression models or econometric models, okay, in which one variable would be declared as dependent and one or more other variables would be declared as independent. Now we are actually trying to not only broaden that idea, like for example, we will be considering in this course situations where the dependent variable may not be just one. You can be dealing with multiple dependent variables at the same time, okay? But we would also say that there are certain techniques in which there is no need to mention dependent and independent variables. Just like Irfan ne abhi kaha na, for example, in which type of situations where you will not mention any dependent or independent, any interdependence concept. So that would be explained in the context of the specific interdependence techniques like PCA and others that we'll be considering in this case. But initially, if you can remember this thing, that there are certain multivariate techniques which are called dependence techniques, and there are certain multivariate techniques which we call interdependence techniques. And why we call them dependence versus interdependence? Because in dependence techniques, dependent versus independent mentioning is that makes sense, while in interdependence technique there is no such requirement that variables should be split into dependent or independent, okay? And then there are specific types of dependence techniques versus independence techniques. So as I was telling you, that commonly used interdependence techniques are these, and one of them is actually PCA, which should have been mentioned here, right? So PCA, which is a closely related technique with factor analysis, these are the two. with which we will be starting. But then there is also cluster analysis, which comes under interdependence technique, because in cluster analysis also, you do not need to mention any dependent versus independent, and the same is the case with multidimensional scaling, which is in short abbreviated as MDS, multidimensional scaling. Okay, let me quickly give you a quick overview, not going into that much detail, but just the idea. For example, what we do in these techniques, just a small collection of techniques. Okay. So when the techniques are dependence methods, when they come under dependence methods, okay, when mentioning dependent versus independence is necessary, then again there are three possible situations. Okay, this one, like for example, one variable is dependent and the other variables are declared as independent. Or you can have this situation where the number of dependent variables are more than one, and then you have this situation, which is a little bit related to the second one, right? You have multiple independent and dependent variables, because this third situation can be actually here and also here. So when you have one dependent variable, right, you can have several independent variables, just like multiple regression. When you have several dependent variables, you can also have several independent variables. So therefore, this third is just, in a sense, combining the other two. So if you have one dependent variable in your techniques, then again, there are two possibilities. Your dependent variable under consideration can be a metric variable, or it can be a non-metric variable. Okay, by metric we means quantitative, and by non-metric we means qualitative or categorical. I hope now all of you have a clear idea when we use the word quantitative versus categorical. Okay, so another name for quantitative variable is metric variable, and another name for qualitative or categorical variable is non-metric. Like for example, income is a metric variable, but for example, socioeconomic status, or for example, the size of the firm in the form of small, medium, and large, this would be actually a non-metric variable. So if the variable has got different categories, it will be declared as a qualitative or non-metric variable. So your one dependent variable can be a quantitative one, or it can be a non-quantitative one. If it is a quantitative variable, then you will be using the technique that we call multiple regression, which we have extensively used in our discussion in the last semester. If your dependent variable is categorical rather than quantitative, then you'll be using a technique that we call multiple discriminant analysis. One of the closer technique which you can use instead of discriminant analysis is something that we have used in our last semester. I hope you remember logit model. Okay, when we use the logit model, particularly the multinomial logit model, then what we do over there, we say that our dependent variable has got more than two categories, and we just go for multinomial logit model. So this multiple discriminant analysis is a competitor of that. As you would see when we discuss discriminant analysis, our dependent variable of interest in this technique would be in a sense representing different categories. So it would be a categorical variable with two or more categories, and you will be relating it with a number of independent variables. So therefore, all this discussion comes under one dependent variable. But you can also have a case of several dependent variables. This is something that we will be actually considering for the first time in this course, because in the last semester, we were just considering a simple case of one dependent variable. Here you will see that in which situations it would make sense that you would be dealing with several dependent variables. So the number of dependent variables would be more than one, okay? But again, when you have more than one dependent variables, there are two possibilities. Those variables, those multiple dependent variables can be metric, quantitative, or they can be non-metric, qualitative. If those several dependent variables in your analysis are quantitative, then you will be using the extension of ANOVA to multivariate case, and we will call it multivariate ANOVA, or what we call MANOVA, M-A-N-O-V-A, MANOVA. So multivariate analysis of variance, or MANOVA, would be a technique in which you will be dealing with a case of multiple dependent variables at the same time. But if your different dependent variables, if they are more than one and they are qualitative rather than quantitative, then you will be using a technique that we call conjoined analysis. Okay, when the time comes, I will be actually telling you, for example, what sort of problems are actually addressed with the help of the conjoined analysis. If you are dealing with multiple independent and dependent variables, you have a case in you have a number of independent variables as well as a number of dependent variables, right? And although it's not necessary that they are all metric, but for example, initially, if we consider that they are all quantitative, then you'd be using the technique that we call SEM. So SEM, in a sense, would be consisting of a large number of variables in which some of the variables can be dependent and some of the variables can be independent. And as you will see when we'll be considering this technique of SEM, right, this will have the flavor of so many other techniques, like multiple regression analysis would also be having a flavor over here, and you will also have a flavor of factor analysis within SEM. So, but because there would be some variables, why this SEM is part of what you call the dependence methods, okay? The reason is that within SEM, you have to mention that some of the variables, one or more, are dependent and the others are independent. So as long as mentioning of one or more variables as dependent is required, this would come under dependence methods. So therefore, SEM is also a dependence methods technique, okay? And then when it comes to interdependence methods, there are a number of interdependence methods, some of which can be classified using similar flowchart on the next slide. Okay. As you can see here, when you are talking about the interdependence methods, okay, the interdependence methods. So one thing which would be quite clear to all of you right now, that we call it interdependence methods because there is no need to mention which variable is dependent and which variable is independent. Rather, we just take them as one set of variables. So again, the next thing is whether these variables are quantitative or qualitative, although they can also be a mixture. But broadly speaking, if the variables are all quantitative, okay, ideally quantitative, then I should also add one further thing over here, okay, and that would be PCA. So in PCA, ideally, the variables should be quantitative, okay, although it can also adjust qualitative variables. Factor analysis, cluster analysis also comes under this category, and metric MDS, right? Because multi-dimensional scaling can be applied if the variables are quantitative. It can also be used if the variables are qualitative. That's why you call something, you say metric MDS versus non-metric MBAs. In all these methods, you just don't mention, I mean, there is no requirement whether the variables should be declared as dependent or independent. Interdependence means that they are all related, right? They are all related with each other without mentioning the direction of relationship. And that's why this forms another set of techniques. Now, a quick discussion so that you have an initial idea. The purpose is not to actually go and discuss all these methods in detail, but some of them so that you have a quick idea, like MANOVA. Okay, MANOVA is which we call multivariate analysis of variance. It is one of the very widely used dependence techniques. Why we call it dependence techniques? Because some of the variables must be mentioned as dependent variables, right? And here in MANOVA, in contrast to multiple regression analysis, in MANOVA, the number of dependent variables would be more than one. So this is a multivariate technique that predicts multiple continuous dependent variables with multiple categorical independent variables. Why we talk about multiple categorical independent variables? Because I hope some of you have some idea when we talk about the n-way ANOVA. Like when we usually apply the ANOVA procedure for our analysis, right? Let me ask from you, just to refresh your memories. कोई बता सकता है कि for example, what sort of problems are handled by ANOVA? ANOVA हम किस purpose के लिए use करते हैं? Anyone? जी, कोई बता सकता है कि when you want to apply the technique of analysis of variance, ANOVA, so what is actually the purpose when you apply that technique? Any idea?
Sir, I think वो statistical difference को हम वो करते हैं उसमें.
हाँ, difference for what purpose? ठीक है, we look for a difference.
Sir, mean के लिए.
हाँ, okay, just to make it simple, remember you use ANOVA, right? When you want to compare groups with each other, right? For example, the null hypothesis in ANOVA, when you say I am using, when you say I'm using ANOVA, so in ANOVA, your basic purpose is to compare groups, okay? The null hypothesis in ANOVA is that there is no difference among the groups. ANOVA is an extension of the t-test. T-test में आप क्या करते हैं? You compare two groups. Like for example, you want to compare Qurtuba University with Peshawar University on the basis of some performance measure. So if one group is Qurtuba University and the other one is Peshawar University, then you will be just applying the t-test. But if the number of universities to be compared on the same performance measure are more than two, then you come for ANOVA. So ANOVA is a procedure in which you want to compare groups on the basis of some quantitative measure, right? वो जो quantitative measure होता है उसको हम dependent variable कहते हैं, okay? In the language of ANOVA, that single quantitative variable on the basis of which, let's say you want to compare different universities in Pakistan on the basis of one performance indicator. Suppose one performance indicator क्या है? The number of publications by the faculty of that university. आप कोई particular year choose करते हैं and you just want to compare the different universities on the basis of the number of publications of the faculty members, right? So this number of publications, which would be some numeric number, This is a quantitative variable because it would change from university to university. And the grouping variable, in this case, would be actually representing different universities. Like code 1 can be for Peshawar University, code 2 can be for Qurtuba University, code 3 can be for Islamic College University, etc., etc. So you want to compare a number of groups on the basis of a single quantitative measure. When we add this M with ANOVA, and we call it multivariate analysis of variance, we say, what if you want to compare different groups? The problem remains the same. You want to compare different groups, but now on the basis of not just one variable, for example, number of publications of the faculty. If you add 2 or more criteria, apart from number of publications, right? You also take, let's say, the number of projects won by university in the same year, okay? So this would be another quantitative measure. X3 can be, for example, another aspect on the basis of which you want to compare universities, okay? So if the number of quantitative indicators on the basis of which you will be comparing the different universities, if this is the case, then we say that you are extending your discussion from ANOVA to MANOVA, okay? So if the variable on the basis of which you will be comparing different groups become more than 1, 2 or more, 3 or more, then you enter into what we call MANOVA, okay? Is this clear?
Excuse me, sir.
Yeah. Yeah, please. जी इरफान.
सर आपने बताया कि एनोवा में हम ग्रुप्स को कंपेयर करते हैं और फॉर एग्जांपल आपने बताया कि फॉर एग्जांपल अगर हम पेशावर यूनिवर्सिटी को कोड 1 दे दे, सरहद यूनिवर्सिटी को कोड 2, इसी तरह ऑनवर्ड. Here we are dealing with the individual universities rather than the groups. सर ये कंफ्यूजन यहाँ पे आ रही है. सर यहाँ पे तो हम
No, we say that if you consider each university as a category, right? If you consider each university as a category and you have one column in your data set which represent जिसका नाम है university, so it would have different categories. Like for example, category, इसका एक category का नाम होगा पेशावर यूनिवर्सिटी, दूसरी category का नाम होगा सरहद यूनिवर्सिटी, तीसरी category का नाम होगा कुर्तुबा यूनिवर्सिटी, so on and so forth. So one column in your data set would be representing the various universities, okay? And the other columns in your data set would be the quantitative indicators that you have measured on those universities, okay? I don't know.
Okay, sir. Thank you.
Abhi clear hai?
Yes, sir. Clear.
Yeah. Okay. So therefore, statistics के language जो हम ये कहते हैं कि you have one grouping variable, यानी एक variable आपके data set में ऐसा है जो कि उन groups को represent करता है. Group number 1 is actually named Peshawar University. Group number 2 is named Qurtuba University, something like that. So by group, I mean the different categories of that variable. And you want to compare these groups, these categories, on the basis of more than one quantitative measure, okay? More than one quantitative measure. So as long as the variables on the basis of which you are comparing those groups become more than one, ideally more than 2, then you call it, you say that I'm using ANOVA, but now I will call it multivariate ANOVA rather than simple ANOVA. And the sense in which we use the word n-way, you can be talking about one-way ANOVA, or you can be talking about two-way ANOVA, three-way ANOVA, four-way ANOVA, five-way ANOVA, right? Depending on कि आपके पास जो data में grouping variables हैं, वो एक है या एक से ज़्यादा है, right? If you want to, for example, compare the employees of an organization on the basis of some performance measures, not only on the basis of their cadre, यानी एक grouping variable आपका cadre हो सकता है ना, कि for example the employees belong to different cadres and each cadre can be considered as representing a group, but you also consider other characteristics of the employees. Like, for example, you also want to compare employees on the basis of their gender, male versus female. So male versus female would be another grouping variable. You also want to compare employees on the basis of some other skills. Okay, so that would be another grouping variable. So if the number of grouping variables on the basis of which you want to divide the units into different groups become more than one, then you say two-way ANOVA, three-way ANOVA, four-way ANOVA, and so on. So just like you talk about one-way, two-way, three-way, and so on, ANOVA in univariate sense, the same terminology can be used in case of multivariate. So that's why multivariate analysis of variance can be used to compare groups on the basis of more than one quantitative variables. So that is actually what we call the extension of ANOVA. Now, discriminant analysis is another dependence technique. Okay, why it is called dependence technique? Because in discriminant analysis, you also have to consider one of the variable as dependent and a number of other variables as independent. Okay, but the purpose for which discriminant analysis would be used would be a little bit different from what you do in ANOVA. In discriminant analysis, the dependent variable would not be quantitative, it would be qualitative, categorical. So this is a statistical technique for predicting the probability that an object will belong in one of two or more mutually exclusive categories, dependent variable based on several dependent variables. I had given you one idea in my last lecture when I was mentioning this data set to you. Okay, this is a data set which represents, for example, information on applicants who apply for bank loan, and the bank is giving them, for example, a pro forma to give information. And suppose the bank is collecting information on these aspects: age, education, years with the current employer, years at the current address, income, debt to income ratio, credit card debt, other debt, etc. Okay. And apart from this information, the bank also has got information from the past customers, यानी past loan applicants ने जो apply किया है. On the basis of that, the bank has also got information on the default status of the employees, right? So for example, on the basis of data from the past customers, the bank has also got this record in their database that whether that person was a defaulter or a non-defaulter. At the end of the loan period, whether the person was able to return the loan or not. So if the person was able to return the loan, the person was declared as non-defaulter, here coded as 0. Okay. For example, if I just take this particular, sorry. Okay, now see, you can see the names yes and no over here. So yes means that the person was defaulter, and no means that the person was non-defaulter. So the purpose of the discriminant analysis would be that on the basis of information from the past applicants, and in this data set, for example, which we'll be using for discriminant analysis at appropriate time, the first 700 customers in this data set, as you can see, are such that, okay, the first 700 customers in this data set are such that the information on their default status is known, right? The bank was able to actually also have this information in their database, which person was defaulter and which person was non-defaulter. these 700 applicants in the record, they are actually old customers, old loan applicants. While if you see from serial number 701 up to the last number is 850, okay? As you can see here, the last number is 850. For the last 150 applicants, there is no information on the last column, as you can see here, okay? So why it is not there? Because from serial number 701 up to the last serial number, they are actually new applicants. They have just applied for loan. So because they have just applied for loan, so the bank has no idea which one of them is actually defaulter or non-defaulter, okay? So what discriminant analysis would do, discriminant analysis would use the first 700 observations in this data set and would come up with a rule, with a rule on the basis of which it would be deciding which person is probably a defaulter and which person is probably not a defaulter. And once that rule is established on the basis of information obtained from known defaulters and non-defaulters, यानी वो applicants जिनका default status already known है, using the information on those applicants from age up to other debt, the bank, using the technique of discriminant analysis, can devise a rule with the help of which it can use information provided by the new applicants, like serial number 701, 702 up to 850. They can plug in the information into that rule, and the rule can then tell them which one of the new applicants can be classified as defaulter or non-defaulter. What would be the advantage of that? The advantage would be that the bank authorities, on the basis of the credentials applied by the new applicant, can come up with some idea which of the new applicant can be possibly a defaulter. I'm using the word possibly because you cannot know in advance whether the person would be really a defaulter or not, but the technique can give you the probability, the chance of whether the person can be possibly a defaulter or a non-defaulter. Advantage इसका ये होगा कि if there is a high probability of default for a particular new loan applicant, then the bank authorities can refuse the loan to that person. And if there is a very low probability, or if there is a high probability of non-default, then the bank would be happy to extend the loan to that person, right? So this is actually the purpose of this discriminant analysis that we have you have seen over here, right? So discriminant analysis will be used in all those situations where you want to classify new objects, new units, into one of the known groups defined earlier. अगर already कुछ groups पहले से known हैं और आप उसकी उनके बेस पर आप classification करना चाहते हैं. One further example would be like, for example, you apply for admission to a graduate program, and the admission authorities have already some defined groups. Like, for example, one group will consist of those applicants, those students who will be granted admission. The other group is those who will not be granted admission, right? So therefore, one group is something like yes, admission given, and the other group is something like no, admission not given. So on the basis of information provided by the loan applicant, discriminant analysis can come up with a rule which can help the admission authorities to decide which person should be placed into the yes category, like admission given, and which person should be given or classified into the no category. The same can be applied in case of job selection, etc., etc. Discriminant analysis would be a very effective technique in those situations. And when the time comes, you will learn how to actually carry out discriminant analysis. Okay, but for the time being, this much detail, I hope it will come up with some rule like this. फिलहाल मैं इसको skip करता हूँ so that we don't just spend that much time over there. When it comes to technique like factor analysis, okay, which would also be somewhat the idea of PCA that we are going to start today. Factor analysis is an interdependence technique, because when you are doing factor analysis, you don't need to, in a sense, mention in advance which variable is dependent and which variable is independent. Rather, the purpose of factor analysis is totally different from the one that we have just discussed. Factor analysis statistically identifies a reduced number of factors from a large number of measured variables. If the purpose of your analysis, apart from others, is what we call reducing the dimension of the data, if you're dealing originally with a very large structure of data, and you say that for some purpose, I want to reduce the size of a data before I can use it for further analysis. So you say, is it possible that the information originally available in large number of variables can be reduced into a new set of smaller number of variables? Statistics की language में इसको हम कहते हैं dimensionality reduction. You want to reduce the dimension of the data. Okay. I will give you a practical example today, so ये पर clear हो जाएगा कि what we mean by dimensionality reduction. So if the purpose is to take information on a large number of actual variables and then try something so that as a result of that process, you get a smaller number of new variables such that the new variables can give you almost the same information as the actual variables, then this is what we call dimensionality reduction. And this is one purpose that factor analysis actually serves. This process,
Sir,
yeah, please. Gigi.
Sir, would you like to share a practical example of factor analysis situation, that in which situation we can apply the factor analysis in which we go for dimensional reduction?
Yeah, exactly. एक example चूंकि हम आज discuss कर रहे हैं, so maybe I would explain a little bit more in the context of that. But in general, when you like, for example, when let's say like, for example, in a particular survey, you want to get certain information from the respondents. They have provided different information to you, and one of the purpose in your survey is to identify certain or to measure certain aspect of the respondents' characteristics. यानी मैं इसको इस तरह आपको example दे सकता हूँ कि, for example, if you ask people what is your income, okay, the most probably income is one of those information which are usually underreported. बहुत कम चांस है कि लोग आपको अपनी exact income दे सकें, and you all know the reason why people usually don't give exact information on their income, right? So you would say, rather than directly asking a question on what is your monthly income, which I know in advance that people would not give accurately, so you say, is there an indirect way of measuring the income, which means, is there a proxy for income, right? ये proxy का word आप बहुत use करते हैं research में. So what researchers do, they ask questions on various household assets. Like, do you have a television in your house? Do you have electricity in your house? Do you have this thing or that thing in your house or not, right? What is the structure of your house? Do you have a toilet in your house, or so on and so forth? So you ask questions about different household assets, and then you say that after asking something like 20 or 25 questions on household assets,